So we're in section 2.3. We're going to talk about synthetic division. So what we're doing today, we're going to figure out how we can divide polynomials. Now before we get into division, I wanted to kind of backtrack just a touch and talk about multiplicity of roots. And a couple of our questions, homework questions, asked us about the multiplicity, and we didn't really have time to talk about it Friday, so I just want to mention it quickly today. If we have, when we're solving a polynomial equation, so we have, let's say we have x minus 3 squared and x plus 2 to the third. When we solve our equation, we end up with our solution x minus 3 squared plus x plus 2 cubed, and that equals 0. We say that the root, this tells us x equals 3 or x equals negative 2. Those are our solutions. I'm sorry, yeah, that works. X equals 3 or x equals minus 2. We say that the root x equals 3 has multiplicity of 2 because we have a second power here. So we have a second power on this parentheses, so the multiplicity of that root is 2. The multiplicity of negative 2, we say it has the multiplicity is 3 because the exponent on that parentheses is 3. So if we solve our equation, whatever the exponent is on our parentheses, basically, tells us the multiplicity of that root. So if the question asks you the multiplicity of a root, what it's asking you is, when we solve it, what is this exponent? The multiplicity of the root is useful, is important, because when we graph this function, when we're graphing roots, the graph touches the x-axis where the roots have even multiplicity. And what that means is if we have a root with even multiplicity, our graph is just going to come and touch the x-axis and go back whatever other direction. So our graph is just going to come and just touch the x-axis. When our root has even multiplicity, our graph touches the x-axis. So this example number 79 that we just did, both of our roots had even multiplicity. So that would have told us that the graph couldn't go through there, it just had to touch. The graph goes through the x-axis when the roots have odd multiplicity. So if we have a root with odd multiplicity, our graph is going to, at that root, our graph is going to go through the axis. Now it might come back down through the axis again, but at that particular root, it crosses the x-axis, it goes through. So it touches when it has an even multiplicity, it goes through when it has odd multiplicity. So this gives you another tool for sketching graphs of functions. So for this particular one, we know that at x equals 3, our graph is just going to touch the axis. And at x equals minus 2, our graph is going to go through the axis. So this is where multiplicity helps us out with sketching graphs. So questions on what multiplicity is, what it tells us about the graph of our function. So y equals x squared, x equals 0 has multiplicity 2. So a parabola, we know y equals x squared just touches the x-axis at x equals 0. And we know y equals x to the third. X to the third has multiplicity 3, so x to the third goes through the x-axis at x equals 0. That's two examples of like that we're familiar with of the multiplicity of roots. All right. So our main topic of today is division. First thing we're going to talk about is long division. And I know you've all seen some long division before. We're going to have a quick review. Let's review how we do long division with numbers first. So let's say I want to divide 7,000. I need to make some more room here because I don't have enough room on top here. We're dividing 7,213 by 61. So we're going to do long division here. So who can help me out here? What do we do for long division? We say, how many times does 61 go into 72? Or we could say, how many times does 6 go into 7, right? So how many times does 61 go into 72 or 6 go into 7? 1. So I'm going to put the 1 here. I multiply the 1 times the 61. And then what do I do here? Subtract. 72 minus 61, I get 11. And then I bring the 1 down. How many times does 61, now we say how many times does 61 go into 111? 1, so I do this. Multiply 1 times 61, I get 61. Subtract 111 minus 61 is 50, and I bring the 3 down. And then we say how many times does 61 go into 503? So I could say how many times does 6 go into 50? How many times does 6 go into 50? 8. 6 times 8 is 48, right? So 61 is going to go into, we're hoping the 61 is going to go into 503 8 times. So 61 times 8 turns out to be 488. And I subtract these, and I end up with 15. And 61 doesn't go into 15 because 15 is smaller than 61. So what this tells us is that 7,213 divided by 61 equals 118 plus 15 61st. Or we could say 118 and 15 61st. So the answer is 118 and 15 61st. So that's how we do long division with numbers. We're going to do the same thing with polynomials. We're going to apply the same exact rules with polynomials. So we're going to go through the same process. So let's look at an example of doing long division with polynomials. So I'm going to divide 2x to the third minus 5x squared plus x minus 8. And we're dividing by, sorry, 8x, yes. No, I want an x there, plus x minus 8. I got ahead of myself and wrote the 8 twice. And we're dividing that by x minus 3. So I start the same way. I say, how many times will x go into 2x cubed? What do I have to multiply x by to get 2x cubed? 2x squared. And I'm going to put the 2x squared here. 2x squared times x gives me 2x cubed. 2x squared times negative 3 gives me negative 6 x squared. Now where we have to be careful when we do long division is we have to remember that we are subtracting. So 2x cubed minus 2x cubed just gives me 0. Negative 5x squared minus negative 6x squared. So I have a negative 5 and a plus 6. So I get x squared. Now I'm going to bring the x down, plus x. What do I have to multiply x by to get x squared? X. X times x is x squared. X times negative 3 is minus 3x. Now we are subtracting. X squared minus x squared just gives me 0. X minus negative 3x, so I get x plus 4x. Or I'm sorry, x plus 3x, which gives me 4x, and I bring the 8 down, negative 8. How many times does x go into 4x? What do I need to multiply by? I can multiply x by 4 to get 4x plus 4. 4 times x is 4x. 4 times negative 3 is negative 12. I subtract. 4x minus 4x is 0. 8 minus negative 12 is 8 plus 12. And I get 4. And now I'm going to stop. So my remainder is 4. This tells me that, and I'm going to write this in red over here, that 2x to the third minus 5x squared plus x minus 8 divided by x minus 3 equals 2x squared plus x plus 4 plus 4 over x minus 3. So we're setting up this so that show the process of doing synthetic division. So this is long division. We do it just like we do the long division with numbers. Now the reason that we're doing long division is we're going to do another type of division that's a little easier, that cuts down on some of these steps, but it only works in certain cases. Long division will always work. So we're going to do, I'm going to tell you a little bit of a theorem about division. We'll do, let's see, we'll do another, I think I'll tell you about our theorem that has to do with division, and then we'll talk about synthetic division. So our division, what we call our division algorithm. Our division algorithm tells us that, and I'm going to write it out in symbols first, f of x divided by d of x, and this equals q of x, and this looks more complicated than it really is. And f and d are polynomials. We are not dividing by 0, so we're saying d of x isn't 0. And the degree of d is less than or equal to f in order to divide. So just like with numbers, we're dividing by smaller numbers. So the degree is less than or equal to the degree of f of x. We call f of x the dividend, just so you have this vocabulary, so if the problem asks you in this vocabulary. F of x is the dividend. D of x is the divisor. Q of x is the quotient. And R of x is the remainder. So you'll see this terminology sometimes about the divisor and the quotient and the remainder. This is what we're talking about when we're doing this division algorithm with polynomials. Dividend, divisor, quotient, remainder, and this is the dividend again. Now if I multiply both sides of this equation by d of x, so I'm going to multiply everything by d of x, I can rewrite that equation as f of x equals dx qx plus rx. So if I multiply both sides of this equation by the divisor, then I get this equation. So this is just what we wrote when we did our division algorithm. We wrote it out this way. We can also write it out this way. All right, so I'm going to show you a shortcut for doing long division. The shortcut is called synthetic division. Synthetic division makes this process a lot easier and a lot faster. Now, a couple of important things to remember about synthetic division. It only works for dividing by x minus c. So we have to have something in the form x minus c. This is the only time synthetic division works. If we're dividing by any higher power of x, x squared, x third, anything more complicated than x minus c, synthetic division does not work. And we have to use long division. So what we're going to do, our process for doing synthetic division, we're going to go back and do the very same. We're going to do the problem 3x to the third minus x squared plus 2x minus 3, and we're going to divide by x minus 2. So the first thing that we're going to do is write the coefficients. I'll put this in red. That's our first step. Write the coefficients of the dividend in decreasing order. I'm going to say decreasing order of power. And we're going to put C in front. And I'm going to put a little space here. Write C in front. C is this number, x minus C. When we write our coefficients, if we're missing a power, if we had x to the third here and no x squared, we have to write a 0. So we have to write a 0 for missing powers. 0 for missing powers. And we have to do that with long division also. Anytime we're missing an exponent on x, we have to write a 0 in our division problem. So what we're saying here is we're going to write our coefficients. So for my first step here, I'm going to write 3, negative 1, 2, negative 3. And I'm going to do it like so. And I'm going to put my C here, we're doing x minus 2. So C is 2. I'm going to bring this first number down. And I'm not going to write out every step. I'm going to explain the steps from here. I'm not going to write them all out. I'm going to bring this first number down. Now what we do is multiply these two numbers. 2 times 3 is 6. And then I add these numbers. 2 times 3 is 6. Negative 1 plus 6 is 5. Now I'm going to multiply these two numbers. 2 times 5 is 10. I write that there. 2 plus 10 is 12. Multiply these two numbers. 2 times 12 is 24. Add these two numbers. 24 minus 3 is 21. And what I've done now, what my numbers here are our coefficients of my quotient. So this gives me 3x, and my exponent is reduced, my power is reduced by 1. This gives me 3x squared minus 5x plus 12, and my remainder is 21. Sorry, that should be plus. Plus 21 over x minus 2. We can't just say R21 because we need to keep track of this fraction. So 3x to the third minus x squared plus 2x minus 3 divided by x minus 2 equals 3x squared plus 5x plus 12 plus 21 divided by x minus 2. If it just asks you for the remainder, you could write the remainder, r equals 21. But if we want the quotient, if we want the answer to this problem, the answer is 3x squared plus 5x plus 12 plus 21 divided by x minus 2. So my power has been reduced by 1, and my remainder is this last number, and I divide by my remainder by the divisor. Yes, Jeff?
Is the 2 from x minus 2, is that a negative or an absolute value?
This? Whatever the number is here. So if it was x plus 3. So Chad asked if this is an absolute value. So if we were dividing by x plus 3, that's the same as saying x minus negative 3. So I would put a negative 3 in front of it.
Okay, so it's a negative.
Right, it's a negative, yes. So let's see, we have time for one quick example. Let's do one more quick example of synthetic division.
So if you don't have it divided by x minus 2, or x minus 8.
So
So if it's divided by like a
like x squared plus 3x plus 5, then you would have to use long division.
And not work?
You can't use long division, or you can't use synthetic division on anything other than something in the form x minus c. You could use long division on that problem, yes. All right, so let's do another quick example of synthetic division. We're going to do 8 plus 6x plus 5x to the third, and we're dividing by x plus 2. So the first thing we want to do is write our coefficients in decreasing powers of x, and we want a 0 for any missing power. So what are our coefficients going to be in decreasing power of x? 5. I have 0x squared, so I have to put a 0, a 6, and an 8. And I'm going to do this. And x minus 2, x plus 2 is x minus negative 2. Remember, for synthetic division, it works for things that are in the form x minus some number. So x plus 2 is the same as x minus negative 2. So I'm going to put a negative 2 here. Bring the 5 down. Negative 2 times 5 is negative 10. I add. I get negative 10. Negative 2 times negative 10 is 20. I add. 26. Negative 2 times positive 26 is negative 52. I add these two, and I get negative 44. So my answer is, this equals 5x squared. My exponent has been reduced by 1. 5x squared minus 10x plus 26 minus 44 over x plus 2. So this polynomial divided by this polynomial gives me 5x squared minus 10x plus 26 minus 44 over x plus 2. So for synthetic division, write the coefficients in decreasing powers, 0 for any missing powers. Bring the first coefficient down. We put our c out front here. Multiply and add. Because I had x plus 2 here. When I do synthetic division, I have to be dividing by something in the form of x minus something. So to get it to look like x minus something, I had to write it as x minus negative 2. So basically we change the sign here. We change whatever sign. If this is a positive, we write as a negative. If it's a negative, we write as a positive. That's the bottom line what we're doing. All right. Tomorrow we will do a little bit more with synthetic division and we'll talk about what synthetic division can tell us about functions. Is really the reason we're doing synthetic division. All right, homework. We're on page 140. There you go.